conservative and non-conservative forces. First of all, we talked before about the gravitational force mg. We said that the work done by mg equals to minus the gravitational delta potential energy, okay, which is equal to minus mg y final minus mg y initial. And also we talked about Fs in the case of a spring. We said omega Fs equals to minus delta elastic potential energy, which is equal to minus k over 2 x final square minus k over 2 x initial square. This relation, this properties of mg and fs, we have the same relation, omega equals minus delta potential energy, and also fs, omega fs equals to minus delta potential energy. We can say that these forces are conservative forces, okay? mg and fs are we can say C. When F, we can say also FC. Anyway, so in this case, the work done by a conservative forces, omega FC, in the case of mg or fs, equals to minus delta potential energy, okay? As you see here in the two cases. This is about the conservative force. We can say also in the case of friction, the work done of F doesn't equal to minus delta potential energy. It doesn't have this property. So Fs or F is non-conservative force, is a non-conservative force. So here we have a classification between conservative and non-conservative. It's clear now. We have a F conservative and F non-conservative. F conservative like mg and fs, and non-conservative like F. In this case, the work done by the conservative force, mg or fs, equals to minus delta potential energy. but the work done by a force non-conservative, like a small f, equals to minus mu n times the displacement. Okay? Now, let me explain another point. You know the kinetic energy work theorem, omega total equals to the delta kinetic energy. It's a general relation between the kinetic energy and omega total. You know, we have omega total. It may be for the conservative and non-conservative force. For example, if we have an object, here we have mg, we have n, we have f, if we have the motion to the right, okay? Anyway, in general, here we have non-conservative force F, and here we have a conservative force F. Omega total equals to the work done by the conservative force F plus the work done by the non-conservative F. Okay, equals to delta kinetic energy. You know, the work done by the conservative force equals to minus delta potential energy. So minus delta potential energy plus the work done by F non-conservative equals to delta kinetic energy. So delta kinetic plus we put here delta potential, we get finally delta kinetic energy plus delta potential energy equals to omega of F non-conservative. In our case here, we talk about small f. Okay. You know, in general, the mechanical energy, delta mechanical energy equals to the mechanical energy 2 minus mechanical energy 1. And the mechanical energy 2 equals to the kinetic energy 2 plus potential energy 2. Mechanical energy 1 equals to the kinetic energy 1 plus potential energy 1. So here we have kinetic energy 2 plus potential energy 2 minus kinetic energy 1 minus potential energy 1. Kinetic energy 2 minus kinetic energy 1 equals to delta kinetic energy. Also, potential energy 2 minus potential energy 1 equals to delta potential energy. So, delta kinetic plus delta potential equals to delta mechanical. Here, we can say this value is delta mechanical energy equals to the work done of F. You know this relation in the last video. We said that delta mechanical energy equals to the total work or equal to the work done by F. And we said here we have an internal energy. This is the value of the internal energy inside the object. In the case, if we have a interaction between the object and the plane. So it's a very important relation here to know what is the properties of the conservative forces. You know, the work done of Fs and the work done of mg equals to minus delta potential energy. And you know the relation here, the final relation between the mechanical energy and the work of a non-conservative force. It's very important. I think that's all about this one. We don't need to go to explain more in details the conservative and non-conservative. Just I want you to know this relation between omega of F conservative and the total mechanical energy, for example, and you get this final relation between the mechanical energy and omega F. Let me resume quickly. Omega of F conservative plus omega of F non-conservative equals to delta kinetic energy. Omega of F conservative equal minus delta potential energy. F non-conservative, it's small f, equals to delta kinetic energy. So finally, we get delta kinetic energy plus delta potential energy equals to omega f, and this relation equals to delta mechanical energy equals to omega f. If f equals to O, in this case, if we don't have f, so omega f equals to O. So if F equals to O, we can say delta mechanical energy equal omega F equals to O. So mechanical energy initial equals to mechanical energy final, and here we have a conservation of mechanical energy.